Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our previous video tutorial 91, we looked at using Sentinel-2 image to create a normalized difference vegetation index for both years, for 2018 and 2024. Remember, our pre and post, we looked at those two images, and then we created a temporal difference image where we subtracted the two images, and we looked specifically for locations or areas within our region of interest that recorded either a significant increase in its ndvi value or significant decrease in its ndvi value. And then we created thresholds, 0.5 and more, and minus 0.5 and less, and we only plotted those locations that, in inverted commas, recorded a structural break in its normalized difference vegetation index. Okay, so we created that we played around with that in that video tutorial 91. So we're going to continue with that in this current video tutorial, and we're going to add a little bit to this. We're going to expand on what we've done in that previous video tutorial. Okay, so remember, once we've generated our Sentinel images, remember there's our Sentinel images, Sentinel image for 2024 and our Sentinel image for 2018. Okay, so we've created those two Sentinel images, and from those images we then created our normalized difference vegetation index for 2024 and 2028. Remember, the ndvi is basically your near infrared band minus your red band, okay, as your denominator. Numerator, and your denominator being the near infrared and the red band. And the numerator we subtract, and the denominator we add, and that gives you a value between -1 and 1. That's your two extreme values. Okay, so you have a narrow band of ndvi values ranging from -1 to +1. Now I can go and read what these values mean, but basically it measures the health of vegetation and the mass of vegetation. The healthier vegetation and or the higher the mass of vegetation, the closer to +1, and vice versa. Okay, so that's what we're looking at. And that created these two images for us. We've created these two images. Let me just go. So that's 2018 and 2024. 2018 and 2024. Now, what I subsequently did is to say, okay, now, remember, we now want to create the two images. We want to display those two images. And for that, we have to obviously create a color scheme. Now, we don't know what the minimum and maximum value within those two images are. Because remember, it ranges from -1 to +1. So, safe side is we say, okay, minimum value -1, maximum value 1. But we don't actually know what is the minimum value within that image and what is a maximum value image. Okay, because what we want to do is to refine this minimum and maximum value here. This is what we want to refine. Because remember, the better your more accurate or more precise this minimum and maximum value is, the better the visualization of your image. Okay, the more optimum will be the visualization of your image. Because remember, you want to present that image in a visual way so that you can identify features or locations that experience X, Y, and Z. Okay, and that's visually what you want to do. So it's important that we have within our visualization parameters, we have these two values, the minimum value and the maximum value, as accurate or reliable as possible. So how do you know these values? How do you know these values? Now, in this case, we know it must be between -1 and 1. We know that. But is it in fact -1 or 1? It cannot be less than -1, it can be more than -1, +1. But we don't know what the exact values is. Okay, so we're going to create a little script This is the script here where we say, okay, indicate to us what is the minimum value, i.e. minimum value, or what is the maximum value within these two images, or within this image. Okay, and that is the script that I use. So in this case, I'm saying I'm creating a variable which is min. Let me just take that. Okay, so let's leave it. But I need to turn min ndvi. So the minimum NDI value, and that's in my NDVI 2024 image. That's the one here. This is the one that we've created there, that one there, which is the equation. Okay, we reduce our region, meaning just for our region of interest, and we reduce the image to generate a minimum value. Okay, and I'm using the scale as 900. Now, what is important is the scale here. Okay, that's quite an important number. Play around with this, you'll see the significant difference it makes in our value itself. I've used 900 because that to me is the most accurate. But this value here makes a huge difference in the value that you're going to generate. Okay, so please bear in mind, if the value that you generate don't look plausible, it could be because of your scaling factor here. It could be because of your scaling factor here. So please make a mental note when you do this. I started with 330 because that's a normal scale, and then the value came out totally implausible. Then I increased it till I get to what? 900 scale. Okay. And then I'm actually just printing those minimum values. And this is what you get. You see there it is. Okay, so it says the minimum NDI value is minus 0.09. Minus 0.09. So I've just made it minus 0.1. So you can see that's very, very far from minus 1. Okay, so if we had there as minus 1, we would be way off. Okay, and then obviously that's the minimum value. And what is my maximum value? My maximum value is 0.69. I rounded up to 0.7. So using this script or this code, I can generate as a minimum value and a maximum value for my image, which I can then use to update or to uh, make my color visualization parameters more optimum, more efficient. Okay, so that is what I do here. Okay, that's how I generated those numbers. Okay, so I'm using this script to generate a minimum value and a maximum value, and I use that then to update this color scheme or this visualization parameters. And then I've just expanded on my color scheme here, my colors, okay, because I know that 0.1, that's going to be quite bad. So meaning 0.1 is NDVI values in the minus or very, very small NDVI values, which means poor state of vegetation or very little mass. Now remember, these images are in summer. So I would assume that there would be a lot of locations would be close to minus 1, minus 0.1. And indeed, that seems to be the case. And then green, blue, and white is the higher values closer to 0.5. So you start here, minimum value. So this will be your minimum value, minus 0.1. And then you increase in equal intervals up to white, which is 0.7. Okay. And that will give you your color scheme. That will give you image that looks something like this. Okay, and then you play around with this. Play around with these color schemes. These colors, and you can increase it, decrease it. That's up to you. Play around with it until you have something that you think is quite efficient. Okay, so again, just quickly remember, how do I generate my precise minimum maximum values? I use this script. Why I want to do this? Otherwise, it's going to be just a thumb suck and say, okay, well, minimum value must be minus 1, maximum value must be plus 1. But that's a massive scale when you force this whole region of interest into that scale. Okay, so that's not very optimum. And that's why I wanted to calculate the precise numbers. The precise numbers. As I said, that's easy, but the big issue is the scaling factor. So please remember to make the scaling factor, play around with it to see what the numbers should look like. I'm not going to do this now because there's a, okay, maybe we just later. Okay, so that's important. Then we subtracted two numbers. Okay, we subtracted two images to get a temporal difference image. Okay, now you see here, I've got my temporal difference image as -1 and 1. Now that was a thumbs up number. I don't know. So our temporal difference image looks something like that. Okay, so it looks something like this. Now that doesn't look either very appealing, it doesn't look very informative, it's suboptimal. Okay, so, and that could be because of this minimum and maximum values not being proper, not being correct. Okay, I have no idea what these numbers should be. And as I said, to play around with this, it's going to take you a whole lot of time because you have to go to a significant sample of locations to get what the minimum maximum. That's going to take a whole lot of time. So I don't know. So what I want to do is I want to find out within this image what is the minimum value and what's the maximum. Then I'm going to substitute it there. So I'm going to just copy this code here. I'm going to copy that and I'm going to put it after I've calculated my map layer, after I've added my map layer. Okay, so I put it here. So I'm not, so it's a minimum ndvi. I'm just going to do temporal difference. I'm just going to put that in, maximum temporal difference. So I'm just copy this one here and I put it in there. Okay, and I'm just going to copy this one. Just please make sure you copy it correctly. Gonna copy it there, put it in there. Okay, and then I'm using my subtract ndvi image, not the original ones, obviously. So I'm changing that to the subtract one, and I'm using that to the subtract one. Now I'm going to calculate the minimum value for this image. What is the minimum value in this image? And what is the maximum value in this image? I'm going to display it. Then I'm going to use those numbers and I'm going to update these two numbers. Okay, so let's click run. And I'm just going to deselect all these ones because I'm not interested in any of them for now. What I'm interested is the numbers. Okay, I'm not going to do that. Okay, so let's go and see where would it be. Temporal difference. Okay, so let's go up again to our space. Where is it? Okay, so we've calculated the minimum ndvi dt, ndvi difference. There is the minimum value. You see it's minus 0.4. I've got minus 1. Quite a big difference. So I'm going to make it 0.42. I'm going to round it to 0.42. And then the maximum value is 0.33. I've got minus 1. So I'm going to make it 0.34. Okay, so you can see that's quite a substantial change. That's not insignificant change. That's quite a big change. So I've decreased the ranges from -1 and +1 to -4.1 to +3.4. Okay, now let's have a look and see how that image looks like. Before we start playing around with the color scheme, let's see how that image looks like. I hope you can still vaguely remember what the image looked like before we made the adjustment. It was quite a dull looking image. You can go back in the video and go and have a look at what the image looked like, but it was quite a dull looking image. So let's see what, just by changing these numbers, let's see what the image looks like now. Okay, so let's deactivate all these these layers. We're going to get to them at some point, don't worry. Okay, so let's have a look and see how. Let's make it a bit bigger. See what that layer looks like, what that image looked like. And there it is. Looks obviously already a little bit different. It definitely looks better. The previous image was much more dull, much more white. This one at least gives you some colors. So now we can play around with it. Okay, so we know. Let's go. Where is it now? There it is. No, no, no. Still. Okay, there it is. So we know the minus values. We want to make the minus values red. So I'm going to go red. Okay. And then I'm going to go brown. Oops, sorry. Okay, so I'm still in the closer to 0 point minus 0.24, that will be red. So the ones that worsen significantly is red. Then I'm going to do a brown, which is a worsening but not as significant as the red. Okay, then I want to go, so now we're going to be close to about 0. And now it is the ones where we start seeing some improvement. Okay, so we start seeing some improvement. So I'm gonna go blue. Let's make it. I don't want to go. Yeah, let's make it. So what color should we do? Yeah, let's leave it blue. Okay. Then I'm gonna go green. Okay, so let's first, and then maybe alt significant will be, like, call it white. Let's just do that for now and see what that looks like. Okay, so remember, so red will be around 0.41 and white will be 0.34, and then it's equally divided plus minus into these schemes. So that would be your layout. Okay, so let's quickly run it again and see. So make a note of it now. This is how it looks. Let's run it and see how it looks after our update of these visualization parameters. Let's deselect on all these oops, sorry, layers, because we're only interested in the temporal difference, the ndvi temporal difference image. Let's zoom in a little bit and see how that looks. Let's, in the meantime, while that's loading, oopsie, look at that. That looks very, very different. That's too much blue. That's way, 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 way too much blue. So what I want to do is I want to include here, make this green, because that should be, most of it should be green, and this I'm gonna make blue then. So I'm just swapping it around. Let's run it again. And this is how you just start playing with the color schemes. Okay, this is until you find something that you're happy with, that looks sort of okay, looks sort of um, that it fits the bill. Okay, so there we go. So something to that effect. Okay, so I'm so there we go. I'm guessing that we may have to include another variable here, because I think there's just too much green. I think the green is too overpowering. So what I'm going to do here is going to do another one orange. I'm going to include the orange here, and let's see what that looks like. Okay, so it's now, I know it takes a bit of time, but I think it's worth going through this exercise simply because um, it improves the visual layout of the image so much more. It just makes the image stand up so much more. And there we go. I think that's something that looks more, yes, I think that's something that we can work with. Yeah, I think that's something that we can work with. So let's stick it with that. So you see where we came from? A very dull looking image that was almost sort of saying very little, saying almost nothing, to an image that looks like this, which is much more informative. Um, And that is, I think, much better presenting an image looking like that than previously. And the first step of creating this image is generating the minimum and maximum value. So this is quite interesting. This is quite neat. And obviously, we know that red is the worst, closer to the minus locations that recorded the most significant decrease in its NDI values, and the white is the locations that recorded the most positive increase in its NDVI values. But you can see the vast majority of locations recorded very little change in their NDVI values. The vast majority of locations over that 4 period or 4 years, ne? Because remember, this is a temporal difference image. So this is much more informative than the previous image or the visualization of the previous image. This looks something that we can work with. Okay, it all starts with generating the minimum and maximum values. Once we've got that, then we can update our visualization parameters. And once we've updated our visualization, we can then update our color scheme and play around with these values or these, first of all, with the colors per se, and then the number of classes or the number of bins. You can increase it, decrease it, and that's how you play around with this until you get something that looks, as I said, something meaningful. Okay, remember, once we've done that, we then said, okay, we want to isolate only those values because this includes everything now. And we already said that now here it's easy to identify the values on the extreme parts, the ones that is more than. Now we also can know what is our threshold numbers. Okay, so that's also a good indication. So if our threshold is bigger than or smaller than 0.42, then there's no values because the minimum value is minus 0.42. So we can use this now for our thresholding. Okay, we can use this for our thresholding. We know that there's no low area or location within our region of interest that recorded a NDVI increase of more than 0.34. So if we make our threshold 0.5, then we're going to be in trouble. But remember, I'm still working with a scale of 900. I'm working with a scale of 900. So just bear that in mind. There might be locations, but we're working with a scale of 900. So just bear that in mind. But it gives you an intuitive idea of what your thresholds should be. Okay, so let's quickly go to the thresholds again. Remember, if I said we want to look at the locations that is greater than 0.3. Okay, because remember our maximum is 0.34, so we want to look at all those values that's 0.3 and up to 0.34. So we want to look at that values, and then we want to look at the values that is less or equal to minus 0. So I'm only interested in locations that meet those criteria. Only interested in the locations that meet those criteria. Now, what I've done here is I've also included this little part here, which is self-mask. Now, this is interesting in the sense that this particular thing, so when the image will be displayed, it will only display the values that meets this criteria. So all those other values will be excluded. So all the values, remember, this will give now a binary image of 1 and zeros. So what it means when I say self-mask this, all those locations that is not meeting the criteria, i.e. has a value of 0, will not be displayed, which is quite, and I'll show you now. Okay, and we do the same there. We create our visualization parameter. Now remember, in this case, it's either 0 or 1. Okay, it's a binary thing, and then we present it, then we display it. Okay, then we display it. And you see it's black and green. Green for areas that recorded an increase in ndvi of 0.3 or more, and red is that recorded a decrease in the ndvi of -3 and less. Now what happens with the self mask, this one, all the values that is 0, which should be black, will not be displayed. Will not be displayed. Let's have a look and see how that looks like. So if I do this, you'll see there and there. Let's quickly go. And you see, there we go. It only displays the two values. um, the binary values. It only displays the red and the green. So why is there's the red? It doesn't display any of the other of the ones that don't meet our criteria. So if I were to take this off, so let me just take that off. You'll see if I just deactivate that. Okay, so let's run it again. Let's deactivate all these ones. I'm not interested in these ones for now. I'm not interested in those ones. Not interested in any of these ones. You'll see now, you'll have two images. You see the black, okay, because that's all the zeros. Okay, that's the black, it's all the zeros. Okay, there's it for the increase, which would be the green, and that would decrease for the red. You'll see it includes the black. So that is what we do here if we say, okay, I want to not show the black because what's the point of showing, because I'm not interested in this. So uh, exclude all those locations that I'm not interested in. And let's run it again. Okay, so let's deactivate again. Let's deactivate. Um, and there we go. Make it bigger. So now it will only display, as I said, the locations that we're interested in. It will not display all those interests that doesn't meet the criteria. Where are we now? There we go. Okay, so it only display the green. What is those green? Those are locations that recorded the ndvi increase of greater or equal to 0.3. And what is the red? Those are locations that recorded a decrease in its ndvi values of -3 and less. And you can see there they all are. Okay, if we just check the include the ROI, we actually should make that black and then it will stand out a little bit more. But yeah, if we can overlay it on a Sentinel image so you can get an understanding where these locations are. So we can overlay it on a Sentinel image. That will give you further indication of where these locations are. But I said, interestingly enough, they're very, very clustered. So if I just delete this on, you'll see they're very clustered. Um, they are locations that recorded either very high or very low increase in NDVI are very close together. And that's farming techniques, I presume. Okay, so that's quite interesting using the self mask, and we can use it in other images as well. Okay, so that's quite neat in terms of improving the images, improving the visualization of these images, improving the information content of these images. That's by the redefining the script, redefining the code, make it a little bit better. Then we can also create, we're not going to go into this, but yeah, all I've done is here is I've just, yeah, let's see what that codes mean. Let's see how that looks like. You'll see if I do that, that's script, you'll see all it does okay, so let me make it a bit bigger. So let's zoom into this particular. So all I'm doing, you see here, what I've done here, okay, all the values will be green and all the values will be red. Using this code, it just gives you different color schemes within each of that. So let me just go increase objects. So let's go increase. Okay, so let's wait for this. So you'll see when we have original, you'll see all of these increases are green because that's what we said. Make all these locations that recorded the ndvi value of -0.3 and more, make them all green. Okay, so they are all green. What we're just saying with this script is just give each of them a different color. So not just all green, let's make them each a different color, and you'll see this is how that looks like. So they're all a different color. Okay, so let's quickly, it's going there, it's just very slow. Very, very, very slow, unfortunately. You see, all of these are now different colors. They're not just green, they are different colors. And this is the visualization, again, playing around with the visualization. Okay, so this is just the code using the kernel, yeah, and it's spatial connectivity, and we're just giving these ones different color schemes. You can see there's a purple, a light green, a green, this color, I don't know what, and this is a brownish color, bluish, and stuff like that. So it's just giving where we initially said make them all green. We're now just saying give them each a different color based on its social connectivity or spatial connect, not social connectivity, spatial connectivity. And that's what we said. And that was just for the ones that's in red, meaning all that one with recorded a decrease in its um, ndvi value. And then we just present it. Okay, so you see, it's not green, just green like that. We actually give them each a different color based on its spatial connectivity. So that's just a bit of coding and script just to improve the layout, the visualization of these images so that we can visually identify more easily locations that meet your criteria or doesn't meet your criteria, or in fact just to generate the criteria itself. Okay, so that's, yeah, just a different way of expanding on your script and to make it more user friendly. Yeah, so before I continue, so that's the ndvi. We've created some nice visual images of our ndvi derived from our Sentinel images. And then we just, as I said, display the original ndvi values. We created a temporal difference ndvi image. And then from the temporal difference ndvi image, we created thresholds. And then we isolated locations that experience a worsening of more than a certain value and an improvement in the NDVR set, and we isolated those locations, and then we presented those locations either just as a homogeneous color or as a heterogeneous color based on its spatial connectivity. So yeah, that's quite interesting. It just makes the thing, the feel of it looks better and more professional in my mind anyway. But again, you don't have to do that. But again, I think it's just the information content, the professionalism just makes it much more appealing and much more effective. Okay. Yeah, so thanks for joining me for this video tutorial. The next one, we're gonna start working on our normalized difference build-up index. And so I'm going to spend the next couple of video tutorials on looking at various indices to isolate urban areas, built-up areas. What are the best, given that this is summer and there's a lot of bare soil. So that poses a significant problem for us because bare soil and built-up have very similar temporal signatures, temporal signatures. So we're going to play around with that. And this is again where our visualization parameters comes important. The work that we've done now becomes important because we want to visually try to differentiate between urban and bare soil. Anyway, I'll say keep this for next video. Yeah, so that's it for this particular video tutorial. I hope you enjoyed it. And as I always say, thanks for joining me on this journey. Please remember to like and subscribe. I really appreciate your effort and your support and your commitment to my channel. Um, and as I said, remember to like and subscribe, share the video, and please feel free to send me comments and input. I really appreciate it. And I'll see you on the other side.